So welcome to our Fastlane webinar, Fear the VPC. My name is Grisha Eckert. I'm a freelancing authorized AWS trainer and also a DevOps consultant for enterprises. And I'm in the area of AWS a few years now. 2011 was the time that I began working with those tools. So quite some experience in this, and I'll try to guide you through the webinar today. First, let's have a few words about Fastlane. So Fastlane is an experienced, award-winning training provider with a wide range of training methods such as classroom training, Flex, and e-learning. Fastlane is particularly specialized in the areas of cloud, cybersecurity, digital transformation, and mobility. As a trainer, a freelancing trainer for AWS and for Fastlane, I can definitely recommend Fastlane as a specialist for technology and business training and consulting services. And I'll show you the web page for Fastlane. There you are, and I've picked out the training course for AWS called Architecting on AWS. That's the training that we picked material from. AWS has generously given us the opportunity to present this to you guys as a form of, doing some marketing for those trainings over here. And Architecting on AWS is a training course. You will learn a lot about, doing architecture, like, decoupling, automation, event scaling, all that stuff. So there's a lot of content in there. This is really a training course, a mixture of lectures and slides plus demos and labs. And of course, we cannot do the demos in here, but I will try as much as possible to show you hands-on insights by using demos. All right, so that's the training that we're promoting. And also, I would like to point out that there is a certification. That's a very important one. That's the Certified Solutions Architect Associate. That's one of the leading certifications in the industry. If have got one of these, you will be considered a valuable, member for enterprises. And there's quite a high, purchasing power getting out of this certification. So you should consider doing this. It's going to broaden your knowledge when you are preparing for the certification, because it's not super easy. So it's rather on the heavier side. And yeah, I will just want to point out that this is something that you might be thinking about doing. All right, so now let's go back and let's just jump into the content. So this module is taken out of that course that I've just showed you, and it's module number 5. We are on day 1. At the end of day 1, I have already been using a little bit of the VPC, and now it's time to make this a bit more, into detail, go into detail, and show what's necessary in order to build a available and secure system in AWS. So on our journey, we now need to build a networking layer for all the devices. We have been starting with using some static assets like a website, and we've shown how to spin up instances, how to use databases, and then attach some storage to all the stuff. And now we need to do, internet routing. We need to do some subnetting, and we will talk about all this in this module. So we are using a fictional company that we're kind of, building up during the course. And right now we are at the stage where we need to manage all of our AWS resources in a net environment. And we want to have some network isolation provided. So we will talk about the VPCs, the subnets, the gateways, and the network security that is part of all this. So first of all, when we begin, let's just start by explaining what the virtual private cloud is. That's the abbreviation VPC, virtual private cloud. Typically, we would rather say virtual private network. However, since VPN is already used for another system, virtual private network, we will show a little bit of this at the end of the course. So the virtual private cloud was the name that they coined. This is a VPC. Well, it's your private network space in the AWS cloud. It isolates your resources from other people's resources. So because you will have a private networking space, other people will not be able to look into your VPC and communicate to your VPC unless you specify so. And that's one of the important parts of the whole thing. So before there was the VPC, for instances, there was a so-called EC2 classic network. So this was in place until 2009, and then after that, the VPC came into existence, and it immediately replaced the EC2 classic network. The classic network has put all of the resources in the same space, so it was basically a flat network. VPCs are structured networks that you can structure yourself in the way that you need them, and we will see how this, how this proceeds. Like, for example, we will be isolating environments networking-wise from dev to test to prod in their own VPCs. So in this scenario, what you will have the ability to is that you will have isolated machines sitting in these VPCs that won't be able to communicate to each other. You don't, make up for this. So they will be fully isolated in terms of workload and network traffic. And in addition, what we get out of the VPC is, you get complete custom access controls on who is entering your VPC, what type of communication is able to be done inside of the VPC, and what all the security settings are for all of your resources. Networking-wise, that's going to be the way on how you're going to be isolating and firewalling your infrastructure. So now let's dive a little bit into the VPC. So what is it? It's a virtual network that's dedicated to AWS account. So one account can host multiple VPCs, and they are either in a IPv4 or IPv6 address range. We will, in this course, talk mainly about IPv4. However, I just want to prepare you that there will be more discussion going on doing IPv6 in the future, since we are just running out of IPv4 addresses. And so IPv6 is going to get more important over time. And of course, Amazon VPCs support IPv6. But since it's a bit of a different mentality behind all this and different philosophy, different concepts, we will not dive too deep into this. If you've got any specific questions, just go ahead. All right. To create specific CIDR ranges, which are IP address ranges for your resources. So you can specify the IP address range that you want your resources to be taking on. So you will be providing IP addresses out of that IP address range. And in addition, as I said, there will be two features that are directly bound to the VPC and that are going to make it possible to control who is talking to your resources inside of that VPC. So you will have inbound and outbound traffic control in the VPC sense. Now that we got our terminology correct, so when we want to deploy a VPC, we need to put it in a region. So you know that Amazon has got all of those different regions around the world, and we will be sitting in West 1, which is Frankfurt, and in EU Central, which is Frankfurt, and there's other regions around the world. So when you create a VPC, you have to put it in a single region. Now, once you got your VPC, it is going to sit and it's going to cover all of the availability zones. Availability zones are groups of data centers that are completely isolated from each other, are separated from each other by a few kilometers, so that any catastrophic event is only going to be destroying or making unavailable just one of the AZs, while the other are still going to be running. So Amazon recommends to have your resources run in at least 2 AZs, and then put a load balancer in front of it, and then you would be able to withstand any downtime for one AZ, and you'll still be able to run your resources in the other AZ. All right, so the VPC is going to span all of your availability zones. So that's an important knowledge you need. All right, okay, so now this is going to be, this was very superfluous and topic-wise. So let's go and see what is happening inside of the console. This is going to help us to understand a bit more, in concrete terms, what actually is being meant by the whole thing. All right, so let's see into our dashboard. So we are currently in the management console, and I will go straight to the VPC. I mean, you can type in VPC down over here and you will get there. So hit enter and VPC, and you will see the dashboard, and you will see all of the networking resources that you have running in your region. And of course, as I told you, I'm in the region of Frankfurt. You can see here, I have picked Frankfurt. And now the VPC, if you click on one of the VPCs, it's the only one that's already there. It's the default VPC. So when you create yourself an account, you will already get a VPC that is existing. So that's the default one. You can, if you select it in your VPC list, you will see down here that there is a default VPC flag set to yes. Yes means that this is our default one, pre-configured. It's going to be a public facing subnet VPC, and we will see how this all comes together. So now in that VPC, you also see, if you go back to the dashboard, that we've got also 3 subnets, 1 route table, 1 internet gateway, and a network control list, ACL. So let's look into the subnets. Let's go back to VPC once again and see its IP address range, because there's a question run here in using IP address ranges. So this is the address range of that default VPC. So that's a /16 address. So this means that the first 16 bits of this address are the networking prefix, and the rest are the addresses of that you can fill out. So this means that you've got like 65,000 addresses to be used as your IP addresses. Now let's have a look into the subnets. We saw that there is 3 subnets, and why is it 3? You will see if you look at those subnets, they're all sitting in the same VPC. However, they've got a smaller address range, so they've got /20 networks. In each of those networks, you can provide up to 4,990 IP addresses. And as you can see here, each and every of these subnets is sitting in a different availability zone. So this is why they have 3 subnets. A subnet can only be spanning 1 AZ. So in this case, we have got 1 subnet. Now, perhaps you know that if you're changing your region, for example, to North Virginia, that there are 6 availability zones. So the default VPC in North Virginia should also be hosting 6 subnets, and that's exactly the case in North Virginia, right? So we got 6 AZs and we got 6 subnets. Switch back to Frankfurt. Now we got our subnets over here. Let's just have a look at one of these guys. And there you have it. So a subnet has got a few things assigned. One of them is, of course, it's sitting in a VPC. So that's its parent VPC. Then it's got available IP addresses that you can use for your instances. And you will see in which availability zone it's running. There is also a network access control list, kind of like a firewall that is sitting and is attached to a subnet. And there's also a route table associated with that subnet. And of course, the important part is the IP address range of that VPC, of that subnet. And this is a subspace of the original CIDR block of the VPC. So in this case, you can see here, that's the 3 different sub blocks that we have got. They have divided these in /20 networks, and I'll show you how this works in just a second. Now that we've got a basic understanding of subnets and a basic understanding of VPCs, let's just go and launch one instance, one machine in one of these subnets. So let's just launch one. Need to pick operating system. And there you have it. That's your T2 micro. This is the one that we're going to take. And now when you want to launch one of these, you have to put in some information. And one of the important ones is going to be the network. Now you can launch your instance and you can pick a VPC that you want to launch it in. So instance is always going to be sitting in one of those EP VPCs. And it also needs to have a subnet associated with it. So in this case, let's just pick subnet for the A availability zone. That's this one. And you can see you still got some IP addresses left over. And now let's click to assign it a public IP address. We will talk about all this. And let's just paste in some user data into the scripts. The guys who have been watching my previous webinars will get a bit bored, because this is going to be always the same web server, always with the same application. And then let's just hit next, pick a drive and say add security group. And now for the security group, we're going to select an existing security group. It's a default security group, and we will take this in order to span it around the instance. This is going to be the second firewall that we are going to be having, and I will show you this in just in a few minutes, how it secures the application. All right, we'll create that instance. And while it's creating, let's go back to our slides and let's try to go a bit deeper into the IP address ranging. So now the VPC has got IP addresses that you can assign to. So for each VPC, you give it a range of private IP addresses that it's going to use in order to get a private IP address. These addresses are private, which means that the resources that are sitting inside the VPC will by default get those addresses. And these private addresses, like for example, 10.0 is the private IP address. The other one that we just saw, 172.31, is also a private address range. These private address ranges can be used by everyone. They will not create a conflict to the outside world, because they don't have to be unique. They just have to be unique inside of your VPC. So every machine that's going to sit in here, every device that's got an IP address, will be able to communicate to other devices inside of that VPC, as long as they've got a different IP address. However, they will not be able to communicate outside of that VPC, because they've got private IP address ranges. Specifically, they won't be able to talk to the internet directly. We will have to do something about this later to make this happen. All right. Now, that VPC address range is specified in a so-called classless interdomain routing notation, or CIDR notation. So that's the one over here. So you can see here 10.0/00/16, which translates to all of the IP addresses 10.0.0.0.255.255, which is around about 65,000 IP addresses that you can use. So that VPC is quite a large one. You can put a lot of instances in here. But now let's look into that /16 thing over here. What this means is that the first 16 bits of that address, so these are bytes, so it's 4 bytes, so it's 32 bytes altogether. So the first 16 bytes of this address are the network prefix. So the length of the network prefix is 16 bits, so 2 bytes. 2 times 8, it's 16. So this might be seen like, an area code for your phone operator. So, for example, Munich has got 089 for the, to specify which city you want to call in, and then the phone number is the rest. Now we've got 16 bits for the area code, and we've got 16 bits for our individual phones, if you want, for our individual IP addresses that we can use. We can specify this slash dynamically, depending on what we want to do. So let's go and see how this works. This is the CIDR notation once again. So if you specify 10 dot, whatever number, so this 10 ranges over here, these are actually a /8 networks, so they're a lot bigger. But you can then pick some of these, like 10.1, 10.2, 10.22. That's going to be your networking prefix. And then the rest of the 2 numbers, like you can see here, are used for IP addresses. However, if you use this as an address, what you basically mean is the whole network being comprised out of this prefix and all of the devices sitting in it. So we can have different sizes of those networks depending on how large the prefix is. The larger the network number is going to be, and the less bits we will have to specify our devices. So you can see here, /16 will give you 65,000 devices, while /17, which specifies 1 bit more on the network prefix side, is gonna only give you 32,000 devices, half as much, and then /18, half as much, and so on, until we, finally arrive at /32, where all of the bits over here are being used for as a network, and then no bits are left for any device wildcards. Then this means the actual IP address actually. So this is how to specify a specific IP address inside of this CIDR notation. And in the contrast, a /0 like here means all IPs. So this is addressing every single device on the internet, right? And we will use those entries for routing later on. See if we got a question up here. The subnets and the routing in just a second, because we got a question, and I'll just show you in just 1 minute and how this all works together. Okay. So now let's see how we need to devise and divide our subnet into a smaller subnets. So over here, what you see, let's have an example. It's a VPC with a CIDR range of /20, which means that we will have 1024 possible IP addresses, because there are 10 bits left for our devices, and 10 bits to the power of 10 is 1024 total IPs that we have. Now let's build subnets. So do we need subnets once again? Because subnets are sitting inside of a specific availability zone. So are sitting in a specific availability zone. We need to subdivide our VPC, which spans the whole region, into subnets. And subnets need to sit inside of that IP address range. That's how it works. We take all of the 1024 addresses, IP addresses, and we subdivide them into at least three subnets. But since division is only leaving us some rest, we will have to divide it into 4 pieces, and then we will use those for our subnets within of our availability zones, and we will leave this one here as a rest for later usage. All right, so now 1024 divided by 4 is 256. Now, 256 would be the number that we would actually be looking for. However, as you can see here, actually there was just 251. So what's the reason? And the reason is that we just cannot use all of those IP address ranges, and we'll see why in just a second. So you see here, our subnets are subsets of the VPC CIDR block. That's important. So we need to subdivide block into individual pieces, and then we will get a subnet that is sitting inside of that CIDR, and they will not be able to overlap. So subnets need to be unique, so they have to be distinct, otherwise there will be conflicts and you'll not be able to create those subnets. Each subnet is going to be entirely within one availability zone. So we're going to put this in AZ8, this in AZ2B, and 2 and 3, and so on, into all of the AZs. And once we got this up and running, we can now place our resources in one of these. An availability zone can host multiple subnets, while a subnet has to sit entirely into one AZ. Now, why is it that AWS will reserve 5 of those IP addresses? So it's not 256, it's 250. Why do they reserve these? Now, the reason is, if you're a bit into networking, there is this address .0 that's reserved. So that's the first address out of your block that's reserved for the network name. So that's the networking part. If you are trying to address that network, this is how you would do it, to take the first address. .1 is reserved typically for the router, and this is what's also done in AWS. So the router is sitting at the .1 address. If you want to access the DNS server, AWS is reserving .2 for the DNS server. There's also a reservation on .3, but that's just a reservation for future uses. It's not used right now. And the .255, or the last number from your range, is going to be the broadcast address inside of that network. So if you want to broadcast IPs, so you want to reach all of the servers, you just do a broadcast on this address and everybody's going to respond. However, broadcasting is not allowed in AWS, so they will filter out any broadcasts. Okay. So there was a question on what 10.0.0.0/0 would mean. So that's nothing that would be sensible to write down, because this is going to mean the same thing. It's meaning the same thing as 0.0.0/0, which means all of the addresses, because you're not specifying anything. So that's not a correct notation. Okay, hopefully this answers your question. And now let's continue. Let's go ahead. And there you have it. Now the next topic that we're going to talk about is the route tables. So route tables are directing traffic between VPC resources. And let's just have a look into a route table in our, because I have already started out a VPC, right? That was the default one. And it already got a route table associated with it. So a route table decides on how to route traffic between subnets inside of your VPC. Now this is the route table here. That's the default one. And you can see here, it's the default one because it says main yes. That's the main route table. So if any subnet doesn't have a specific route table associated with it, it won't be sitting without a route table. It's going to take the main one. So that's into the routes. And you will see here, there's two entries here. So the first entry is the CIDR block of the complete VPC. So what this actually means is that as long as you stay within your VPC CIDR block, IP address range, you're going to be able to communicate locally, which just means, any device, any two devices that they want to communicate, they can use the local network interface to talk to each other. So this means if you're sitting in VPC, just talk to each other. It's going to be allowed by default within the route table. So that doesn't mean that it's going to be allowed using the firewalls, but the routing says just talk to each other, guys, your neighbors. Now, for everything else, this is the rule that's in here. So /0, 000/0 is being routed to the internet gateway. So what this means is that, any other address, so everything that's not in here, is going to be routed to the internet gateway. Routing tables are built in such a way that the longer prefix is taken first. So this first filters out all the IP addresses that are from the local VPC. And if this rule doesn't hold, if your IP address is not in that range, then we will go to the next rule. The rule says, please send the packet out to the internet. And we will see how the internet gateway works in just a second. But that's how a route table works. And as you can see here, if you go into the subnets in one of these where we put our instance into, you'll see that there is a route table associated with that network. And this route table is going to tell us that it's putting all the packets into the internet gateway. Now our EC2 instance should be up and running. Click on it and you will see here what we got is an private IP address that's sitting in the range 172.31.19.53. This is what the HTTP server has given the address to our instance. Now, besides that private IP address range, it also got a public IP address associated with it, because I have clicked this when I try to start the machine. Now, what we will try to do is we will try to access this machine, and I can already tell you that it's not going to work because I have not put in the correct firewall in front of the machine. Show you that access is not going to be allowed. Even if there's a route to the internet, we still don't have any connection up and running over here. And the reason is that we have put a default security group on that machine, and that's the firewall of this machine. As you can see here, the default security group is in here, and it allows all outbound traffic, but it doesn't allow any inbound traffic. So you can see here, all traffic from all types and all ports is allowed, but only from this source. So this source is the security group itself. So anybody that's sitting in that security group could be potentially talking to each other. Since we only got one instance, there's no neighbor, so no communication is possible between the guys. But this basically means that we don't have any entry that allows us to talk from the outside world to the inside world. And then on the outbound side, all traffic, all protocol, all port range is allowed anywhere on the internet. So that's what it means over here. So outbound, everything is allowed. Inbound, basically nothing is allowed currently because we don't have anything that rules. So no source IP address for this. All right. Now we saw that we do get an error when we try to communicate to this instance. Now let's go back to understand the route information right now. So what it says over here, that our route tables are directing traffic between VPC resources. They are required to direct the traffic between VPC resources. Each VPC has a main default route table, and you can create custom route tables. We will do this later on when I'll show you how to work with these custom route tables. All subnets must have an associated route table. If they do not have it, the main route table is going to take over and it's going to be, putting the correct routing entry in there. So typically when you've got a VPC, which would be a private VPC, so no connection to the internet, default one does have a connection to the internet, but if you wouldn't have a connection to the internet, this is the only entry that you will see in the routing table, which would just allow communication between the devices, but there would be no entry to the internet. So that will be a routing table that is destined to be private. And as a custom, you can assign custom route tables to each subnet, and that's also a best practice from Amazon's side. And we will just see in a second how this all works. Now, besides having subnets for AZs, we can also have subnets to separate the public instances and resources that we have into private instances and resources that we have. So not only do we have a separation between the AZs, but we need to have a public and a private subnet. So in this case, what it means is that we're going to separate two more. One is going to be used for internet routing and one is going to be used without internet routing. So one public subnet, that its routing table will have an entry to the internet gateway, the one that we had in the console. As you saw, there was an entry to the internet gateway. So this was able to talk to the public subnet and it's going to be able to receive traffic from the subnet. While in the private subnet, there was no communication going in and out. So a private subnet doesn't have that entry to the internet gateway, and it's not directly accessible from the public internet. Now, there is a special use case, or not so special one, where you would have resources sitting in that private subnet that would also want to talk to the outside world without being able to receiving traffic from the internet. So like initiating a communication, like for example, if you want to download a package from GitHub, you would need to have an internet connection up and running while still not being able to get accessed by the internet. In this case, what you would do, you would create yourself a NAT gateway, and the NAT gateway kind of like allowing outside traffic, not allowing inside traffic, because it's netting the resources. Okay, so now let's look into internet gateways first. So the internet gateway allows communication between your instances and the VPC and the other way around, and it looks like this. You would have your users or the user group or clients, whoever is working with your environment or your machine here. That's a web server, for example. You would open up this for outside usage, right? Because a web server, most of the times it serves the public, right? Like Wikipedia, if you want to access Wikipedia, you need to open up that firewall and a route to your instance. So how does this work? You create yourself an internet gateway, you launch an instance IP address range. This is what we did with our instance. You put it in a public subnet, and then you need to have a route table like this. So apart from the local targets, a entry for the internet gateway itself. So that's the /0, so meaning every address being routed to the internet gateway. Now, if you've got all these conditions in place, you are in a public subnet, your instance has got a public IP address, your internet gateway is started in your VPC and is attached to the VPC, and you got this route table, and this route table is associated with this subnet, then traffic is going to be able to get into and get out of your VPC to this instance. So this is the way on how to create, internet accessible, internet routable traffic. For the net gateway, what you would want to do is just get traffic out. So for downloading stuff from the internet, but not getting traffic into your environments. Oops. So in this way, you would need to create yourself a so-called net gateway. A net gateway is a thing that is sitting in a public subnet. So we need to create this. And it's not created by and it also costs a little bit of money. So it's a few cents per hour. So you need to keep track of this. And you will have to have one gateway sitting per AZ if you're using multiple AZs. Otherwise, communication is not going to be possible to the outside world. Now, how do you create all this? So why would you want to use a net gateway? You want to use a net gateway when you are setting your instances into a private subnet, but you still want to have them downloading stuff. So in order to do so, you create yourself a net gateway, you put it in the public subnet. You have your public subnet set up correctly, you've got your internet set up correctly, and now the only thing that you need to do is you need to create a special route table, your private subnet, and associate it with the route table. And now what you want to do is, now in the private subnet, what you want to do is put in the /000/0 IP address and route it to the gateway. So in this way, any packet that is destined for the internet is going to go via this route to this device, and then via this route entry to this device, and then it's going to go to the outside world. Now, this is what you have to do in order to get, private instance data, outgoing data out to the internet, but the internet is not going to be able to reach your IP address, your instances within of your network. All right. So there's a few questions here. I can see. Yes, does it allow broadcast? How does ARP work for hosts at the subnet? So ARP is going to be working, but you are not able to use the broadcasts. And there's another question. Can I have disjoint subnets in my VPC, say 10.0/0/24 and 172.16? No, you cannot have those sitting in the same VPC because the subnets have to have the parents, that's the VPC's CIDR range. So you cannot have a subnet using another CIDR block that is not within your VPC. So they have to be, part of the VPC. However, you might be able to add IP address blocks to the VPC. So you might say, okay, I've got a VPC that's got a 10.0 network, and then you've got a 172.16 network in the same VPC, and then it's going to work. And I'll show you this later on when we are done with the presentation, how this would possibly work. All right. Now let's go ahead and let's see when you would put where you would put your instances. So for example, if you've got databases, put them in a private subnet, of course. If you've got anything that's doing batch processing, stuff like that, it should be sitting in the private subnet. Backend stuff, put it in the private subnet. And a web server, of course, sits somewhere in the public, or if you don't allow public traffic, you might be putting it in the private subnet also. So if you just an internal application, for example. All right. So subnet recommendations, you want to have larger subnets over smaller ones because you're going to lose a few IP addresses out of the subnet ranges. And you don't want to have like many small subnets, and it's going to be complicated to keep track of all that stuff. And so use larger subnets and just a few. So typically, this is going to be the scenario that you want to be looking for. So you'll probably have something like, a subnet group per AZ, and the subnet group is going to be consisting out of a public and a private subnet. So if you got a public subnet and a private subnet per AZ, then you're going to have twice the number of subnets as you will have AZ. So if you got 3 AZs, you're going to have 6 subnets, and this is what you want to go for. Typically, what we want to do is we want to create smaller subnets for public subnets and larger ones for private ones, because typically we do put a lot of more instances inside of a private subnet. But that doesn't have to be so. But that's just the typical, it's a suggestion. What happens typically in what people are doing. Okay, before we go into the ENI, let's just go back to our instance and let's see what's happening on the instance side. So we are in our EC2 dashboard. We got one running instance. You can see here it's got a security group attached to it. That's not completely, the full truth. The full truth is that there is a so-called elastic network interface, which is over here, that's being attached to our instance. So you can see here, this is the kind of like the networking card that is attached to the server, and it's attached to that instance ID that we are using, and it's in use. And this is its public and private IP addresses over here. So that's attached to the elastic network interface. Also, you can see here, in actual fact, the security group is attached to the ENI, not to the instance. So that's an important distinction. So I just want to make sure that you understand this, and that there is there's a way to detach those interfaces from your instances and still have them up and running. So if you, for example, want to create an interface over here, you can do so. So this might be for a management interface for SSH, for example. And then you can give it a specific, subnet. You can assign the addresses in a custom way to this, and you're going to give it a security group by default, and then you can create that ENI. So that's now a network card, like buying a network card for your server. Typically in bigger data centers, this is what people would do, is they would use a management network to communicate with that instance, and then you can attach it, a specific instance, to this one. And now you've got 2 network cards attached to that instance. This one is a primary one, and this one is a new one that I just attached to it. And it just got the private IP address because I've chosen to do so. And now you can use both of these for specific use cases. Back and understand this over here. So elastic network interface, this is what you've got, and it's a virtual network interface that you can put onto your instances. And you can have a private IP address and a IP address and a MAC address assigned to this ENI. They of course bring their own addresses with them when you are starting them. But there's virtual network cards, right? That's not physical. So there's some software-defined network sitting behind all this that is making this possible. As I've shown you, you can assign multiple ENIs to one instance, and the reasons to do so would be plentiful. So you can, of course, create a management network like here. You can use it for network and security appliances. If you have like a firewall inside of your VPC, you can use 2 network cards, incoming and outgoing. You can create dual-homed instances that are sitting in 2 network segments, like in 2 subnets. So that's a dual-homed instances. So this is what you could use an elastic network interface for. Elastic network interface is also used for elastic IP addresses. An elastic IP address is a public IP address that you can take from the space of AWS. You will get it assigned to a ENI, so it's going to be sitting there. It's going to be costing you money. It costs around about the same amount as an instance. It's not attached to an instance, and I'll show you the reason for why this is the case. So because it blocks one IP and IP are expensive, this is the reason why you have to pay it if it's not assigned to a instance. So you can attach an elastic IP to an instance, and then you can reassociate it and rebuild all the stuff. So you can see here, let's go here and have this IP address being reassigned from the main server to a backup server when the main server goes down. So this is what you can do over here. So that's the reason why you would use elastic IP addresses. So you would have the communication going to that elastic IP address, and then once the server goes down, you can then just reattach it to the backup server that's serving the same application. And now the users will still be able to connect to that same IP address and be able to talk to that hot backup instance that's doing the same stuff as the other one that just went down. So providing high availability in this case. Now let's jump a little bit into the security group discussion. We already saw security groups in place. So they're sitting around our application servers. In actual fact, they're sitting around the ENI or sitting in front of our ENI. They're restricting packets. So they can be used as virtual firewalls. They can be restricting stuff into the application server and also out of the application server. And these guys are stateful, which means that because there's two ways of communicating, right? You can initiate a communication sitting outside of your security group and talking to your server, and you're trying to initiate that communication. And this is what the inbound security group rule is going to control. And once you got the connection established, because the security group allows the traffic to the app, packets are also going to be allowed to go out. So this is what it means that the rules are stateful. So initiating a communication into the security group, if this is allowed, then outgoing traffic is also going to be allowed as a reply to the request. However, the initiation of a traffic from the inside to the outside, this is being controlled by the outbound rules. Security groups have inbound and outbound rules that you can use, but once you are allowing outbound traffic, returning results IP-wise are also going to be accepted. Their rules are stateful. When you the security group, the default security group or the empty security will block all inbound traffic, so nothing is going to be allowed by default to enter your instance when you're spinning one up. And the instance is going to be able to talk to the outside world, initiating traffic outbound. The default configuration. So now it's going to be your business to designing the security groups in a correct way. So correct way would mean we would have a security group sitting around our database that's going to be, comprising out the data security group, and we will create a security group sitting around both of these servers. So it's going to be one security group host both these application servers. You will have inbound rules for each functional layer, and this will look like this. So you will chain your traffic. So this is the way that packets are going to flow. So if you've got an application, typically you will have multiple tiers serving in the background. So you will firstly access the web server, then the web server is going to decide on which application server to talk to when to access the application server. The app server is going to access data and is going to return all the stuff back to the end user. Now, for the inbound rule, what you're going to do is just open up necessary only and only this. So if you've got a web server and you want to serve the whole community that's sitting on the internet, the source address would be everyone, and they will be able to talk to your web server using the port 443 and HTTPS. Now only this should be allowed and nothing more the web server, and there should be no direct traffic from the internet to the application server and also no traffic to the database server. Only the website itself will be able to talk to the application server on its port, and then the application server is going to ask for data from the database, and only the application server has got the right to do so, so only the application server should be opened. So you should really design your security groups as tight as possible, because otherwise you're going to lose on security-wise. Right? And this is, by the way, the reason why we couldn't talk to our instance. Now let's just go back and let's try to enable this. Now that we know what was the reason, let's go to the security groups. Our default security group, and we will see, as we already saw, that there is no ports allowed to speak from the internet to our machine. So let's create a new security group. Let's give it a name. There was a phone call. So let's give this a name, and let's say it's the security group. We have to give it a description, and it's going to sit in the VPC. So it's spanning all of the subnets, and it's also spanning all of the AZs. As you can see here, by default, there is no inbound rule, and the outbound rule says that everyone can talk all of the IP addresses in the outside world. So initiating a communication to the outside world, not a problem. Inbound, nothing is possible. So let's just add a rule. Okay, now we got a rule. It's HTTP. Now let's allow HTTP. And now you can see here the source of this traffic. So where the traffic can come from is from all of the internet. So as soon as I create this, the whole internet is going to be able to talk to that web server. But I'll restrict this. I'll just put in my own IP address. So only my own IP address /32 is going to be allowed to enter that machine. So let's create this. We got our security group over here. Now let's go to instances. Let's grab our instance. It's this one here. And let's go to actions, and let's say, and you can see here, I can change the security group. So let's click on security groups. You can see here, I got this one active, and I will uncheck it, and I will check new security group. And then let's say assign security groups. And now there you see there's a new security group assigned to the instance. In actual fact, it's assigned to the network interface, as you know. But now you understand, and you see here, wow, we got our application up and running. And then you see our boring little, nice little game going on over here. I have already lost. Okay, so let's go back. And this is how we allowed, incoming traffic to our web server using port 8. Typically, it should be port 443. It should have a certificate up and running because, HTTP is not secure. All right. Let's go to the next one. So after there's being talk about security groups, let's talk about network access control lists, or knuckles. That's the short way of saying this, knuckle, right? Knuckles are also firewalls, but they're not sitting in front of instances. They are sitting in front of subnets. So at subnet boundaries, this is where you would have network access control lists. They will allow all inbound and outbound traffic by default. So the one that has been created by default will allow everything, but you can then, tune it down as you need it. So these are steps, which means that if you're allowing incoming traffic, you will also have explicitly be allowing the outbound traffic also. So you will have to do this manually. So this is how this might look like. So traffic entering that subnet is going to go through the corresponding knuckle. You can see here, the last rule says that everything is denied, and there's only one rule that's doing some allow, and that's the one that says SSH is allowed to this address, and that's the allow statement over here. And that's the outbound one. So this one says that outgoing traffic from this address is allowed to pass out. So this is the corresponding. So if you've got an inbound one, this is this one. If you've got an inbound one, you also have to create an outbound one. And the reason is that this is stateless, so it doesn't remember the traffic entering into the subnet is also allowed to enter outside of the whole thing. So in this case, you need to understand that this is going to be specified as all the upper ports, all the high ports in IP lingo. All right. So this is what you would do using knuckles. Now, why is there two? Knuckles have been preceding security groups. So security groups is the newer concept, and it's okay. It's also much more usable in terms of user experience. So use security groups if you want to, allow stuff. Now, there's one difference between security groups and knuckles, and the one is that security groups are deny by default, and then you're only allowing stuff. So you just cannot say, if you see here, into that security group, what you can say, I want to allow inbound stuff. So you can add rules to allow stuff, but there's no way to specify and say, okay, this IP address over here is going to be denied explicitly. So why would you want to do this? You could say, okay, I want everybody to talk to my let's say anywhere. So I want everybody to talk to my web server, but the Grisha's server, I want to, forbid. So this IP address, I don't want to enter my server. There is no way in the security group to do something like that. So in such a specific scenario, you might want to consider using knuckles. But that's really a special use case. But this is what it's going to be used for. Also, if you want to do, traffic routing based and traffic filtering based on, then this is what you want to do if you want to use knuckles. There is also another firewall to make it even more complicated. That's the web application firewall sitting in front of application servers. That's going to also be able to black and whitelist IP addresses if you're interested. All right. So that was knuckles and security groups. You really need to understand this type of communication, and specifically, just tying it all very tightly in order to get the communication boundaries set up nicely. So that's going to be your main work as an architect, because you need to make this whole thing secure. Don't open up traffic. Don't allow everybody to SSH into your machine. There's going to be harmful people doing harm to the servers. Try to do a lot of stuff. So at some point in time, you might have a Bitcoin miner sitting on your application, and it's going to cost you money. And you will only learn about this when the bill is going to go up. So be careful when doing this. All right, so now let's have a look into using VPCs and using multiple VPCs. You can use multiple VPCs per region. And why would you want to do this? Well, there is a use case for just one VPC where you will have just, small amount of resources, and you just put everything into your VPC. So for a lot of use cases, this is going to be a bit. So there is going to be two options that you can go for: multi-VPC or multi-account. If you're going for multi-VPC, what you're going to do is you're going to have a situation like this. You're going to have AWS account sitting on top of all this. So this is going to be your account. And then inside of the account, you can put multiple VPCs. In this case, you won't be, or all of the resources that are going to be scheduled to run in one of these VPCs won't be able to talk to the other VPC directly. You can still enable this by using VPC peering. That's the methodology to do so. However, by default, not be able to do so. If you want to enable VPC peering, you need to make sure that the VPC ranges are disjunct. So it means that if we got 10.0 over here /16, we should have 10.1 over here and 10.2 and 10.3 over here. Otherwise, when you will try to do VPC peering, it's not going to work. So you need to consider this when you are designing your networks. So don't blindly take those IP address ranges. You need to consider, doing it seriously. So You can do multiple VPCs inside of an account, or for small teams, like putting in here, putting testing over here, putting development over here, and having some shared resources over here. And in this way, the communication between those resources will not be possible. But sometimes that's just not enough. In this use case, we do have governance and compliance standards that may require higher workload isolation. And then we need to go for a multi-account pattern where you would have an account per project or an account per stage. Project A is here, sitting here, project B is sitting here. Having a different account, all of the resources are fully isolated between each other. So this account cannot see any resources that are being scheduled over here, not only networking wise, but also from the management perspective wise. And this is what you could do if you are, if you want to be more independent and you have a higher isolation. Now, you can still make it possible for this to communicate. It's just possible to do VPC peering between these. You can still share resources between these. We'll have to allow this explicitly, while in the other case, in the previous case, that was, the other way around. It was allowed by default and not disallowed. So, okay. Now, what you need to consider is that there is some VPC limits. So if you are sitting in a specific region, you will see that per region and per account, you will only get 5 VPCs by default. So creating more VPCs is gonna fail, and you will need to increase that service limit. And the VPC amount is not limited hardly, but so there's no hard limits on VPCs, but there's a soft limit of 5. So you can increase this by using the support formula. So you've got multiple VPCs in here. Now you're good to go and create yourself, environments fully isolated working wise. And this is how you would go about this. Okay, now let's see if any questions in the meantime. So you've got question, how does routing work when you've got multiple VPCs? And we can have a look into this question. So let's go back to our console. Let's go to our VPCs. So we only got one VPC, but I can create multiple ones. And as you remember, there is a limit of 5. So let's give it a name, VPC A, with a IP address range of like this. It's created. So automatically it creates a route table entry. Oops, over here. It creates a route table entry for this new VPC, and it creates a default network access control list VPC. New one. And let's give it a disjunct block of IP addresses. So I'll take the other one. By the way, the maximum number, the shortest prefix for VPC address ranges is /16. No bigger network is allowed. And let's create VPC B. Now that we've got both VPCs in place, we would be able to, so they're not finished yet, right? We didn't assign any subnets, so on. Well, let's create a peering connection between these two guys. There's a menu over here, peering connections. So to create a peering connection between two disjunct VPC, this is what you can do. So you can ask, you can give it a name. So let's say this is going to be peering A to B. VPC A is going to ask for permission. So you have to ask for the other VPC owner to get VPC peering up and running, because these guys could be sitting in another account. And then if they are sitting in another account, probably they won't be, they will have to accept your request to do a connection, right? So it's going to be asking, is it in the same account? Yes. Is it in the same region? Yes. Who's going to be the acceptor? Is going to be VPC B. So A is trying to make a peering connection to B, and then let's create it. You can see here, this peering connection has been requested. We've got a request we need to, we need to accept it. And you can see here, there's a pending acceptance. So the other guy in the other account or whatever it is, they would get this, they would get this question. Do you want to accept or reject that request? And you can say, I want to accept this. Now I would have peering between the two VPCs. So let's accept it. So now it's been accepted. However, and now that's an important one, there's no routing between the two at the current time of being. So what we would need to do is we would need to go to the tables of the VPCA, and what we would need to create a routing entry. Now, let's say 10.1.0. So from A to B, we have as a routing is the peering connection, and this is the peering connection. And now every packet that is being destined for the other VPC is going to go through that target, and it's going to be directed to the other VPC. So now you save the route, and now you've done this for one route table, and now you have to do this for the other route table. So this is going to be this one, and this is going to be using the same peering connection. Now you've got them paired. And now, if you had any subnets in here, you would be able to, to send packets between those two. I hope this answers your question, Faisal. So guys, I'll show you how to create a, the rest of the so that you can use it. We will create a public and a private subnet. I just wanna have you guys, put some questions if you have them before I go and do all this. So nobody's screaming. Let's go and create a subnet. So typically, when you create yourself your VPCs, you wouldn't go and do it like manually doing it here. It's going to be a lot of clicking, as you'll see. There's other options. You can, if you go to the dashboard, you can launch a VPC wizard that's going to help you out, doing all the public and private subnet and the net gateway, and it's going to spin this all up for you in the background. Also, another way of going for this is to just say, let's go for quick starts. In our CloudFormation webinar, you will already know that there is a VPC quick start that you can use. Let's go and make this English. So this is going to be the scenario that you're going to build when you are creating this VPC quick start. So you just start it by clicking on this button over here, how to deploy. You just say launch the quick start, and it's going to ask you a few parameters, and then it's going to build exactly this nice VPC that's going to span multiple AZs. It's going to have a public subnet. It's going to have a private subnet, possibly even a second one if you want to. It's going to give you some spare capacity. It's going to create yourself an internet gateway, and it's going to create net instances or gateways, and everything is going to be connected up nicely, so you can just start. And if you say, oh, okay, I want to modify this, that's not finished yet, so that's not how I would do it. You can have the source code for this quick start, so you can see how the actual template is being built. It's a bit complicated in the meantime, so they've done a lot of customization in here. So that's the CloudFormation template. It's a few pages. So how long is it? You have a few thousand lines of code. So you will have to go through all this, but you can customize this yourself. So if you're interested in doing this before starting out and doing your VPC by hand, you can just use one of those, quick starts, and they're already there. Okay, so one way would be to create that CloudFormation template, and the other thing would be to just do it by hand for just to just experiment around and see if this is something that you might want to do. So let's get let's just pick one of the VPCs. Let's just pick this one. Let's just create a subnet in here. So let's create a subnet inside of that VPC. That was VPC A. We want to make it private, let's say. So for private, that was VPC. What was the name of this guy? A private A. And we have to put it in an AZ. So let's say AZ A also. And then let's give it in the, let's put it into AZA. Let's pick a IP address block. Let's just say, okay, for this one, I'm gonna pick this address range, and this is gonna be the size of the whole thing. So leaving me 251 addresses for this subnet. Now you can create that subnet. There you have it. Now this subnet, what it's got is it's got the default route table associated with it. So any resource that you're going to launch in this subnet is going to have the ability to talk across the two VPCs, because we've created that routing table entry in here. So that routing table entry is going to make it possible to talk to the outside world. Now, not everybody be delighted by this. So you might say, oh no, that VPC, that's a private one, that shouldn't be able to talk using the VPC cross VPC connection. So that's the wrong routing table for this. So let's give that routing table a name. So that's the routing table for peering. So that's not what we want to use. So let's create a new route table for our VPC. Let's give it a name. So that's going to be a private route table. So let's use this for private communication. So there you have it. And now what we need to do, we need to go to the subnet that we just created, so the private, and go to route tables. And you can see here we got a route table association with the main route table, which is doing the peering. So let's take the private one, and now the subnet will only be able to communicate the resources that are sitting in the same VPC. Now we got our private, really private subnet, and this is how you would go about this. Let's say, okay, we need to multiply this for the other AZs. Okay, that's not what we're going to do right now. Let's say we want to create a public subnet. So to create a public subnet, let's just give it a name, public A and the AZ. And let's pick the same VPC. Let's put it in the same AZ, and let's give it another address range, because now we are in the, we need to, subdivide that block of CIDR, and let's give it this IP address range. Okay, so now we got the private one and the public. We want to filter out only the subnets that are corresponding to this VPC. So what you can do here is to just take that VPC name out of here and the name of it and put it, oops, here. Then you will have a filter, and you'll only see the two subnets that are part of that VPC. All right, so now with the public one, the public needs to have an internet gateway. So let's create an internet gateway. Here it is. Let's create one. Let's give it a name. So that's going to be the internet gateway IG or IGW. That's the correct shortcut for VPC A. You have it. Now we got the internet gateway. The internet gateway is still detached, so it just exists, but it doesn't do anything. By the way, the internet gateway is highly scalable and available by default, so you don't have to deal with all the complexity in here. So let's attach it to a VPC. Let's put it to our VPC A. Now this is attached, and potentially this would now be enough to talk to the internet. However, our subnet, if you look the public one, if you look into their route table, they will be able to talk to the other VPC, but they will not be able to talk to the internet because there is no route table that's talking to the internet. So let's create ourselves a new route table for the internet communication. The name, RT, say public A. Let's pick the VPC. Have it. So now let's edit the route entries. So we need a new route in here, and the route is going to be for internet. It's going to be every IP packet for every address except for this one. Please go using the internet gateway, and which one? The one that was attached to the VPCA. And now when you save your route, the route is ready to be used. And now we just need to go to our subnet, to the public one, and change the route table association, because now it's the wrong routing table. Let's just change it. Let's pick the correct one, which was the public one. Now the routing entry for the internet is in here, and now you can save all this. You click close, and a public subnet that is able to to talk to the outside world. To make it even better, let's have a look. There is a thing missing that's called auto assign public IPv4 address. It's still set to no, so let's make this to a yes. If this is set to yes, all of the instances that are going to be launched inside of that IP address range, inside of that subnet, is going to get the public IP associated with it as soon as they get launched. So this is what we want to have typically. So let's say save. And now this is what I would consider to be a public subnet. You have got the choice. If you go into EC2 and you say, I want to start an instance, go, pick one instance type. And now once you're in here, now you can pick and choose your other VPC. Pick this one, and I've got the option of taking the private one in AZA or the public one in the AZA. So let's take the public one. As you can see here, now you're going to be getting assigned a public IP address in here. So when you say start, it's going to be placed inside of that VPC, inside of that public subnet, and it's get the public IP address range. All right. Any more questions, guys? The question, can you bring in your own IP space into a VPC? And yes, you can. That's exactly possible. So if you've got your own IP address range, you can bring it into the VPC. So I'm not sure if I can show you an example. Let's go to VPCs. I can add this over here. Let's create for the first. You've got that VPC, you can assign other CIDR blocks to it. You can add CIDR blocks. Edit CIDRs. This is where you would be able to in your own IP address ranges. So you can, yes, you can. And you will have to be the owner of that IP space to bring it to AWS. So AWS is going to check if this is actually the case. Otherwise, you won't be able to do so. Owner of the IP address range, and if you can, if you can show this to demonstrate this to AWS, they're gonna you're gonna be able to this to your VPC address range. In the we also have got that statement in here. It supports bringing in your own IP address prefixes. So yes. Here's another question. Does AWS announce the range for me, or do I have to bring in a circuit to access it from my network? If you're accessing this from your own network, we are in a different discussion, because now what's going to happen is we'll do some stuff over here. Probably you're going to set up a VPN So you can go for side-to-side VPN connections where you can set up a VPN connection between your on-premises data center and AWS. Or even if you don't want to use a VPN, a tunnel, you can also go for direct connect. So if you go for direct connect, you will have direct connection to AWS. You can get a 1 gigabyte or a 10 gigabyte networking connection directly as a MPLS connect, for example, so a dedicated line to AWS. How this works is you can set up this connection using requesting it first. You will have to have an MPLS connection to a provider like Equinix that is partnering with AWS, and AWS will provide a switch port for you. So you can then let the provider connect your MPLS connection to that switch port. And in this way, you will be able to connect your two data centers. Now you will be able to advertise your connections and your IP address ranges directly into the VPC. Questions, guys? So if not, I would like to say thank you for being in the webinar. Hopefully it was interesting. I would, of course, like to point out that we've got trainings on this that's going to be going deeper down that line. Visit us on our website, and I would like to say thank you very much and have a nice weekend.